used to work was that there were two hydropower sites on the same little river or the same stream that has, it's quite a high mountain, right? So it comes from like over 2,000 meters height and goes down to 1,400 meters. And there used to be two spots for hydropower on this little river. So one further up, the water was running through it, then it was going back to the stream, and then there was another one further down, and the water was going through there. So you basically had, sorry about that, you basically had two little hydropower plants, but only one of them was operational. And now the basic power formula for hydropower basically depends on the flow rate available and the height, the head, or like the height difference that you can use to produce electricity. So now by increasing the head, by combining these two hydropower plants, you can get the same power with less water. So this way, since in dry season you obviously have less water, by increasing the head or more than doubling it, you are less dependent on having high flow rates available. And this is where you have a better power supply in dry season, where the flow rates are obviously a lot lower.
Okay,
so
yep. So for after the combination, the machine house one will not be used, right?
Exactly, yeah. But machine house one is already not used. So the problem was this project developed like over many years, far before EWB was even close to being involved there. And so the machine house 1 was built first, and the machine house 2 was built, and it's quite tricky to combine them both in one off-grid energy system, and also it was too expensive to run too. So this way, basically right now machine house 1 is not used, and the power capacity of this machine house is now being used by increasing the head and combining it of the two.
Okay, got it. Thank you.
Yeah.
Go to the second question, please.
Yeah.
Hi, Johan. We have a question considering the targeted group of the island.
Mm-hmm.
So I read this guide that there's a model that's called ABC that targets anchor business or community. What's the goal with this project? You wanna target a specific business or big industry, or just clarity? We're referring to phase 4 specifically, right? Phase 4.
Yeah. First of all, like the goal of the project is not really defined by EWB, but more by the local stakeholders, right? So that's their project. We support them in that. So it's important to remember that this is not really our decision to make, but the original goal of this hydropower project that started before EWB was involved was to supply electricity to this industrial campus. So the industrial campus, if you follow the ABC scheme, I would say could be like a typical anchor user. And what they do there is this is a space for small businesses or small industrial consumers like mills, workshops, small manufacturing. So that's the main goal. What's important to note is that the hydropower plant this site does not have the capacity to power like large-scale electrification on the island, and therefore it's kind of important to kind of use the capabilities in a smart way, and also minimize the cost for a distribution grid. And so the original goal of the local actors was to mainly supply the industrial campus. And then when you follow this ABC scheme, like it is quite possible that once you have a solid supply for one spot, and you maybe also add further power generation from solar or something like this, then you could possibly extend it to the nearby communities. But the main focus right now, and also the main interest of the local stakeholders, was small manufacturing and small businesses.
I think maybe adding on to that is we saw the graph of the current demand, where there's demand throughout in the afternoon that is not met with just hydro. If you think about the scope, will it mostly be covering this demand, or should we think ahead? Think ahead like a decade or a decade or two. Would there be enough demand to cater for that extra supply, or should we think smaller first about just covering that bit of supply?
Yeah, the question of demand estimation and prediction in off-grid systems is like it's a pretty tricky one, and also focus on a lot of research actually. I guess one thing that you have to take into account with the existing system is that the hydropower capable or potential is quite limited. So I would say any possible demand exceeds this at all times. So the hydropower plant is basically completely used, if you want to call that. When it comes to further demand growth or further, I would expect that you could say the industrial campus itself, you could probably calculate with some fixed growth rate. But again, that's very tricky depending on a lot of factors. When it comes to energy demand growth with new access, so basically if you electrify a village or something, there's actually quite a bit of research on this. So I was already told that there were questions about this, so I checked for some papers that I actually cited myself in something I wrote about this. So there is quite good research about what happens if, for example, the community gets new access to energy and how their demand will continue over time. But again, there are like very high insecurities about this, or uncertainties about this. So I guess what you can do generally is always expect demand grows quite rapidly also. This is like a very general assumption. Yeah, I guess this is maybe not the exact answer that you were hoping for, but I guess what you can say is expect, like, it's good to say, or at least to have the capability or the possibility to extend or to add additional generating capacities in the future.
Yeah. But in this case, the finance budget, it's very important to add any capacity or to meet the demand. So because we don't have any feasible data of how much our finance budget is going to be for stage 4. So how we can add the calculation on that?
Well, I'll ask from Johan. I think you're on mute, Johan. I don't know.
Sorry, I didn't understand that.
Yeah, so no. Maybe are you concerned about the cost for the stage 4? Or are you not concerned about the cost for stage 4?
Well, I guess you could kind of look at it the other way. So if you want to create like a self-sufficient energy project, I mean, there's not really an exact limit to your initial cost, but there's more a feasible price of electricity or levelized cost of electricity that an operator of this grid could achieve with different energy systems, right? So what you can, a better way to look at it is say, okay, we have a demand of, let's say, what is the typical demand for off-grid energy? Let's say like 5 megawatt hours a year. That would be like a community, for example, and then so 5,000 kilowatt hours. So and now you calculate, you design an energy system that would cover this demand. Then you look at then you can estimate your cost for this energy system with your interest rate and everything. You can estimate a yearly cost, and then you can calculate how much each kilowatt hour of energy would cost. So then you have your levelized cost of energy. And this way you can kind of estimate, okay, which levelized cost of energy can we achieve? So you look at your demand, then you try to match your energy system in a way that you don't have a lot of excess generation, because that you can sell, that drives your cost without driving profit. And then you calculate the levelized cost of energy. And the next step is kind of to look at what the ability to pay is of a local community. So levelized cost of energy, in Western countries, for example, the ability to pay for electricity is quite high. In the global south, it's often a lot lower, or in developing countries. So I would more or less look at it from the other way. So make a demand estimation, then see which energy system you would need to cover this demand, and then calculate which levelized cost of energy you could achieve. And not say, okay, we have a fixed investment cap or something like that.
Yeah, and it's a business case anyway. So you need to argue about, like business case in the sense you need to show what's the return of the project, how long it would take to return the cost of the investment, So when those things comes into place, I think you'll have,
So I think you have to demand first. Set demand first, and then the capex of the size, and then realize the cost.
Yeah,
because that's what you're thinking. If we increase the capacity bigger than the right now the conceding rate, then it can, for the investors, they may not going to get back the profit instantly, because the population is increasing. So if we right now they need 120 and we wanted to make it 200. So there's a big gap to make the profit. They need to get back. People need to use the energy. They will pay, and then the investor will get it in return. So
yeah, but I think Johan's answer is the best answer. So it all comes into the cost per unit. What's the what's the value? So
Okay, I think we're going to the online team, guys. Online team, you got another option for questions?
Yes, we have. And we have a very beginning question. So, have you team think about other power generators, such as wind power generator?
Sorry, I didn't completely understand this. Could you just repeat it, please?
Yep. So, because we considering why your team choose the hydropower, instead of other power generators such as the wind power.
So as I said before, the project developed in the way that there's a local organization, a local initiative that started this hydropower project, and we are supporting this local initiative. So it was never EWB's decision to make, which generation technology we're using there. At the same time, I guess if we would have to make the decision at the beginning, you would pick hydropower, or we would have picked that as well, because if you calculate it, hydropower actually gives you one of the lowest levelized cost of energy you can achieve, especially if you use it for small industrial consumers that have often a higher nighttime use. So, I mean, the only other renewable generation technology you could use on EG is solar. And solar generally has a way higher levelized cost of energy than micro hydropower.
Yep, thank you.
Why not just expand hydropower then? Just make it triple.
Yeah.
That's
the thing with hydropower is that it's highly site specific, and your site limits your potential very much, right? You have a maximum flow rate, or you have an economical, feasible flow rate that you can use. Like the River Tama, for example, I think has like a maximum of around 200 liters per second flow rate. That's like a small stream. I think these numbers don't tell you much, but 200 liters per second, that's not much. That's a small stream. And in dry season, it has only a tenth of this, or 30 liters or something like that. So you can't use more water than you have access to. The other thing that you could increase is the height difference. And again, this is limited by the topography. You know, like the topography there gives you like a certain available head that you can use economically, and also just other factors like the land you have available. What is your property? Where are other people using the stream? So the hydropower site is actually used quite to the maximum now with this planned project phase 2. So that's why, and yeah, we did some energy economic optimizations, and if you assume your hydropower potential is larger, the optimization will always tell you use the maximum of the hydropower potential before you add any other power generation capacity. So yeah.
Noted, clear. One more question with regards to the solar plant system that is proposed, or that we're going to propose for phase 4. Is there any predefined location where we want those panels, or is that part of what we need to propose?
No, there's no predefined location. Generally, I would say this is quite flexible. I mean, of course, you would have to buy land for it, or at least, yeah, make it available in some way. And it's also a good idea to think about some cost associated with this. Even if you're using your own land, you can't use it for anything else, so you have to discount that. One thing I would propose if you decide for a location is checking for the connection cost of a solar power plant. If you put it, you know, if you have a grid that has like kind of a central distribution point, it's quite smart to put the solar plant somewhat close to the central distribution point, because otherwise you just have high access cost for connecting it to the existing grid.
It makes sense. Thanks.
Just adding to that, when you said the site, we need to acquire land for the site. Is that one of the options, or is that the option in the initiative, in the local initiative? That is that we need a farm instead of just doing like roof-mounted systems, for example.
Okay, yeah. So the question roof-mounted versus non-roof mounted is in developing countries usually quite easy to answer, because they always or almost always use non-roof mounted, so ground mounted solar systems. So this comes from the land cost being generally not very high. The quality of houses on EWB, I would say, are often not, they don't make it easy to install roof mounted solar panels. Maintenance is harder if solar panels are on the roof, and the cost in general is lower if you don't roof mount, because roof mounting means that all the electrical connections have to go up on some house, and often if your house is not big enough, which is mostly the case, you have to distribute it on multiple roofs, which drives cost again. So often for the sake of cost efficiency, you don't use roof mounted.
When I said roof mounted, I was referring to the actual industrial campus, so the mills and the hatchery and all that. So I would think these are kind of relatively large in size, as in roofs. So that's what that's something.
Yeah, they are. Well, actually, the industrial consumers, they are quite small, so the houses are not very large. I would say they're probably comparable to the average residential house you would know from Australia. But I think yeah, the same applies there. It would be possible, but there's not really. You don't have really lack of land. Land is not too expensive, and roof mounting on these houses would be quite tricky. So I don't think they would do this in any way. And actually, on EWB, there are multiple small solar projects, and none of the ones I saw personally was roof mounted. And in Rwanda, I've seen quite a few too. They were all ground mounted. So I think it would be very uncommon to do it in any other way.
That's clear. Thanks.
All right, online group, you're next.
Yes. So I was wondering if we can get the approximate number for the expense of each state, so we can predict like how much we gonna cost on the stage 4. So we're gonna do the cost management.
Sorry, I didn't get the first part. What kind of
I think,
number do you need?
Johan, I think I'll answer that question later on. I think that's
Alright.
that's a question for me, Ruhi, relating to the project. Yeah, I think, yeah, because we will be meeting you, all the groups after you submit your progress report in a week. So I think we can have a chat during that session about that.
Okay, sure.
Alright, sounds good.
Okay. Sorry, we'll go on. Yeah. So aside from coffee production and the industrial campus, what are the other main industries? But I do know you also mentioned the smaller industries, so it would be good to have an understanding on, what industries. Yeah.
So you're asking for on the industrial campus, right?
Yeah.
No, the question goes as this. So I think you previously answered, Johan. So basically, the idea of the project is to power up, to provide the supply for the industrial campus. So technically, we're not interested if there is another set of industries outside, correct? We focus on the industrial campus demand, yeah?
Yeah, that's, I would say that's the aim of the project, yeah. And if I understood correctly, the question was now what kind of demand you have on the industrial campus, so what kind of industries?
Yeah.
Okay. So, I mean, there's a detailed list that I don't have available to me right now, but I can kind of try to remember. So the industrial campus is doing kind of like agriculture industries. So they're focusing a lot of production of agriculture products and manufacturing of them, or like the first stage manufacturing. So you have the big consumers, you have the coffee mill, you have the corn mill, you have an oil production where they use, I don't know which plant they use for extracting oil. You have a soap production, you have chicken incubators, so where chicken eggs are hatched, I guess. Then you have they built a fish farm, so they basically grow small fish that are then set in fish farming outside on the lake. And then you have a wood workshop, currently under construction, a metal workshop, or carpentry and metal workshop. And I think that was, and then you have, they have, what do you call this? Yeah, they grow chicken, but that's not or they have like a chicken farm. That's not really an energy consumer. But yeah, I think this was complete.
No, all good, Johan. The original question, just to clarify for everyone, was if there is industries outside industrial campus. We got with your clarification, everything that is in there is in the industrial campus, and we focus on that. So there's nothing outside that we need to focus on. So it's clear. Right?
Yeah, I think for you, there's nothing outside that you have to focus on. But just to clarify, there is a lot of small industry outside of the industrial campus as well.
Okay. Yeah, thanks.
It's not in the scope of this project. Yeah.
So, what would be the interest of the local? You said the traditional leaders. So we have to actually get them on board with this project. So, what would be the interest? What would be like they agree or not agree depending on what factors? If my question.
Yeah, that's a good question. So, I mean, I met them personally, and my impression and what everyone says also is that their main interest is like a good development of the region. So especially with energy access projects, it's quite tricky because you often have people who profit directly, who get energy access, and many others who don't. and to kind of balance this this interest gap, I want to call it, is quite tricky. With the traditional leaders, I guess their biggest interest is socioeconomic development of the region, and this industrial campus plays an important role there. So it generates income for the local community. Young people can get training there. There is a better availability of locally produced goods. So it's like quite a clear benefit for the local community, and I would say the local leaders are quite dedicated to that goal themselves. So would be their main interest. That would be their interest.
All right, that's really good because me thinking it's out of government coverage that they would be one thing that would be just to get back at the government. So it's like we did it on our own, like we developed this, we did this, and without your presence. Is that something that we do in this case? For example, just I don't know, physical. Yes.
So you mean that that the independence from the higher up government, the provincial and national government, is important to them?
Yeah, is that something that they would do?
Yeah, so I mean the relationship of the rural areas to the higher up governments in Congo is pretty complex, and I'm really not an expert in it, so I don't want to say too much about it, but my experience and what many people told me was that people kind of learned that they have to be self-sufficient in a way to get local development done. So people in DRC, from my experience, were very they don't expect much of higher up government. They don't expect much to be done for them, especially when it comes to infrastructure, education, stuff like this. So the local community and their leaders, they're quite eager to get things done by themselves because they think that's the only way to get development going.
Yeah, thanks.
I think that also addressed to one of the questions you had, right? The interest of the local.
Yeah.
We captured that one before.
We sort of have more like what was the level of community involvement?
Yeah.
And I think you broadly covered that.
Yeah.
But if there's anything you want to add on that. No? Okay.
I think that's pretty.
Yeah.
That's pretty good.
One more from the online guys, and then one more from us. Oh, well, that's it. Yeah. Online guys.
Yep. When we look into the image that you gave us on the website, we can see the power line was connected by some kind of single wood column. So is there any situation, any risks when there's a bad weather, such as strong winds?
So bad weather and strong winds are quite common on EG. And the power line that was built in project phase 1 was designed to be resistant against quite bad weather. So the wind poles, they're designed with a lot of how do you say it in English? A lot of security to make sure the power line holds also in really bad weather.
Backup, maybe.
Okay, so there's no situations happen like the power disconnecting during the day.
Mm-hmm. Yeah, so there are actually, I mean, power outages, especially in off-grid energy systems, are quite common, a lot more common than you would expect in places connected to national grids. But that's generally not because of the power lines and the connections, but more because of your generation capacities. So since you only have one, potentially in the future 2 generators, like solar and hydropower, if you, for example, have to do maintenance on them, you have to shut down the whole grid. So you have power outages. Sometimes a power outage from a fault would be lightning strikes are generally a bigger problem because then you have overcurrents. They shut off the generator and some electronics in the grid, and then you have to restart it. But the connections themselves, they're quite solid. And the project phase 1 has been finished 3 years ago, and from what we've heard, or from they didn't have any problems with the electrical connections since then, but they had a number of problems with the generation capacities.
Okay, thank you.
Yeah, Johan, I read in some papers that there are different hybrid solutions, some that consider photovoltaic and diesel and batteries, some that consider a mixture of both, some that only consider photovoltaic solutions. Are we constrained to any of those, or it's up to us to define which one would be the most optimal? To be more specific, should we consider just photovoltaic? Should we consider batteries as well, diesel as well, or just one of those solutions?
Yeah, that's a very good question, and actually interesting because I've worked on basically optimizing energy systems in the past year, and the question which technologies you consider is always a big one. First off, if you use a hybrid energy system with solar, you almost always need a battery storage, and the minimum a very small one. And that comes from the fact that your solar generation is quite variable, even just between minutes or hours of a day. If you have the sun shining and suddenly a cloud moves up, your solar generation for just a few minutes can drop by 50% almost. So to be able to have a stable grid, you almost always need a battery bank. So this is the first thing to consider. When it comes to using a diesel generator, I would definitely not limit it and say, okay, we can't do this. And I would definitely, if you do like a case study, I would always consider all available options and find the cost optimal one. Of course, with diesel, you could argue that for some non-economic, non-technical reasons, we rule it out. But I wouldn't do that. So if you use like a normal optimization approach, you can kind of say, okay, this is my diesel price. Is there any way that a diesel generator or a small diesel backup generator could be economical? So I would definitely consider that. So solar, battery, the hydropower plant, and diesel. What you then have to look at is wind power. I've often been asked if wind is an option on EG, and the answer is no. It's not an economical option.
It's too expensive to do.
Yeah, it's just not enough wind. Yeah, the wind potential in EG is close to zero, I would say.
And then you just talked about daily fluctuations, that is outside the backup. How is it with seasonal fluctuations? So do you perhaps know how much efficiency you can achieve during the rainy season?
So the solar power has basically no seasonal fluctuations on EG. If solar power you can quite well estimate from solar irradiation data, which is geoinformation data that is available. I can point you, if you are interested in this, you can check out PVGIS. It's a tool that uses geoinformation systems to calculate solar yield of a specific site using freely available data sets. So I've been using this quite a lot too.
Johan, can you add that to the chat, please? Maybe just
I can send it to the chat. 1 second.
look at that and circulate. Thanks, Johan.
Yeah. So, and if you, I really recommend you use this tool. You can select the point on the map, and basically it gives you the solar potential for a specific point. So you can select exactly EWB and see. What you will see is there's no season or barely any seasonal fluctuation, which makes sense. You're almost right at the equator, and the sun is almost shining. The cloud cover from rainy season actually seems to make not too much of a difference. The big seasonal fluctuation you have is the hydropower, right? From dry and rainy season.
Yeah, and
So that's a fluke. Yeah, sorry.
And then the companies at the industrial site are used to those fluctuations. They're used to working with a bit less in certain seasons.
Yeah, absolutely. So what they often do is they even they adapt their demand quite well to the availability. But at the same time, one hope that they also have with adding another generation capacity that doesn't have the same seasonal fluctuations like solar, is that you get a little bit less dependent on that, because of course you can adapt to it, but that always comes with some drawbacks.
Yep. Definitely clear.
Online team, more questions? We got probably one more, and that's it from our perspective. Online guys?
I think we don't have any question.
Okay. All right, Johan, the last one from our team. We understand on the previous phases from 1 to 3, there has been like a heavy involvement from the local community in terms of deploying the projects, right? The hydroelectrical plant, and also in the operation. So we're thinking we will propose the same for the solar plant, right? Is that a right assumption? So we'll get the people in the island to install the system, and then we'll train them and give them some training for them to operate the solar plant in case of a fault or something like that. Is that a good assumption?
Yeah, absolutely. That's a good assumption. And it's a very good goal. At the same time, it doesn't make your project easier. It makes it more sustainable, but definitely not easier in the first step of execution. So, or of building a project. But if it's always a good idea to get as much as local involvement as possible.
Got it. Thanks. I think that's it from us. Okay.
Okay, thank you.
You guys, one more question about the demand requirements. Because just reading on the project documents, at the end of phase 2, it says that during the rainy season, it produces about 120 kilowatts. And during the dry season, it almost drops to 30 kilowatts.
Mm-hmm.
And looking at the graph provided in one of the project documents, is that the peak demand is about 90 kilowatt. And that just puts me in a bit of pressure, so that if the demand is 120 and the 120 is created, the demand is 90 and the 120 is created during the 9 months, what would I need to cover during the 9 months of the rainy season? Is it still the daytime peak, or is it something?
I think I don't have the document in front of me right now, but I think one thing to consider with this demand estimation is basically that this is unscheduled demand. So that is, let's say that the assumption is made, okay, you have unlimited access to energy, how would it be used and which peak you would have? That doesn't mean exactly that your off-grid energy system should cover exactly that demand, because demand can be shifted to other times, limiting peaks and making the whole system more economical. When it comes to covering demand, one thing that to look at often is like your total energy demand during a year, so not power peaks, but energy, and then you kind of assume its standard load profile and calculate peaks from that. So I think going into like optimization of off-grid energy systems is a little bit too much for right now, but I guess I could help point you towards the right direction. I think. So yeah. So the answer is the demand with the project phase 2, like you can assume that daily peaks could always be higher than the maximum your system is able to generate. You know, if everyone in the industrial campus decides, okay, I want to run my machinery now at 8 a.m. in the morning, then you will most definitely not have enough power available, even with the perfect flow rate in rainy season. But of course, this is something that doesn't happen because people schedule their demand. Yeah.
Right. Online guys are good, right? No more questions. Online team, just rechecking. Rechecking. All good?
Yeah, we are good.
All right. Okay. Seems that's all, Johan. Thank you very much for your time, and I'm glad we could find a time which suits both of us, because last time you were talking to our group at like 2:30 a.m. Yeah. Still we managed to find time. So yeah, we could find this time. I hope so. Whatever you feel like sharing, depending on the questions, just send them to me. So I'll pass it to the students. So for you guys, we may be able to talk to Johan maybe one more time, but finding a time from him is not that easy.
That's right.
No, so, but yeah, let's see. Right?
Very, very good.
Thanks, Johan. Appreciate it.
Thank you.
Thank you. Just one recap so I don't miss anything. The only thing I've written down to write in the follow-up mail was the plan or a sketch of the existing system, like a single wire diagram. Is there anything else? Any other follow-ups that I missed?
No, I think that's it. No, not from our side.
This is demand requirements. I thought you had something to just point us in the right direction for demand requirements and equations.
Okay.
I mean, in that regard, would you suggest to use the GIS model or use a Homer as a simulator or do something simpler?
Yeah. So Homer would be the standard tool to use. That's like I guess the most common one, and it also has a demand estimate or like a demand profile generation functionality. So if you are already familiar with that,
no, I'm not, but
yeah, you know about it, so that's already really good. That would be actually one thing I would point you towards. There are a few tools available for this. Homer is a commercial one, but it has an open. You can use the trial, I guess, for your purposes. That's very feasible. So I would really recommend starting with Homer, and I guess that would be also the first direction I would point you towards. If you're a little bit more seasoned with like Python or something, you could use some open models, some open source tools. For example, off-gridders is one that's programmed in Python. But I think Homer would be the easiest one to get started with. Yeah.
thank you.
Thanks, Johan. Thanks online guys. We are supposed to meet not Johan, but I'm supposed to meet you guys after you submit the progress report. We will give you a feedback probably within a week, and then we will have a progress review meeting. So every team will have 1 hour just for us to have a chat. All the questions I can pass to Johan, and he's quite prompt with responses.
Yeah.
Thanks, Johan. Appreciate it.
Thanks, Johan.
Thank you very much. Have a good evening. Bye-bye.
Thanks, guys.
Thanks for guys.
That was a good session. All right.
Really, 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 really,